Alright guys, hi, welcome back. We are here where this is part 2 of our TSI review, function attributes. Now, what are function attributes? Basically, the characteristics that would be exhibited by a determined function. It's very easy to see. We could kind of tell on these graphs very easily. This U shape is a characteristic or an attribute of something that's considered to be a what? Right? Over here, a characteristics of something that looks like a line. Right? And similarly, a function. Right? And each function has little bit of attributes that we kind of make connections with or we'll look for. Now for quadratics, a couple simple things that we look for is, first of all, these points right here. What are these called? You said x-intercepts? You're correct. But guess what? X-intercepts have other names as well. X-intercepts are also known as roots, zeros, solutions. Now keep in mind that x-intercepts always follow the idea of having an x value, but the y value is 0. That's how x-intercepts are. And this is important because, hey, if they give you a table, you can figure out which one's the x-intercept if you simply look for a point that looks like this. So keep in mind, x-intercepts have roots, zeros, or solutions are another names for x-intercepts. Another nice looking point that we always tend to look for is this point right here. Sorry. Ooh. This point right here. And what is that point called? Y-intercept, exactly, because it crosses the y-axis. And just like the x-intercept, what's very important about this point is that we have a y value, but the x value is what? 0. This one doesn't have other names, but simply put, that is our y-intercept. Now, for this quadratic, we also have this point down here, which is called the vertex. And then we have an imaginary line that crosses through this vertex, which is called, y'all remember? The axis of symmetry. Remember that all vertical lines are always x equals and whatever number it has. The vertex always has an h and a k. Basically our x and our y value. Like in this example, right? Let's go ahead and kind of define all our situations. We have two x-intercepts. That would be -5, 0. And we would have 1, 0. We have a y-intercept. That y-intercept would be 0, -5. We have a vertex. The vertex point would be -2, -9. And the axis of symmetry would be x is equal to the x value that we have there, which is -2. Those are the main characteristics of quadratics. Linear. We look for the same things. Boom. This point here. Oh, let's switch color. This point here. That's our y-intercept. That would be 2, 0, correct? We have another point here, which is our x-intercept. Remember, it has other names as well. And that point would be negative 2, 0. Oh, I messed up, huh? This should have been 0, 2. If you caught that, good job. All right. Right, and as well, linear equations have something called the slope, which is a rise over run. And you get to choose 2 points. It rose to, it ran to. Slope would be 2 over 2. What's 2 divided by 2? 1. So each function has its attributes. I'm not going to go and talk about other functions. I'm going to leave it with these two basic ones. But there's two main points that we always try to look for is the y-intercept and the x-intercept. And most of these graphs always have them. Now I want to teach you how to find them from very simple forms. From standard form, we're going to start with the y-intercept. The y-intercept is very simple. It's simply the constant. So in standard form, the y-intercept will always be the constant. What's the constant? What's the constant? The term without a variable. So look at this example here. Boom, which one doesn't have the variable? This part here. So guess what? My y-intercept is 0, negative 18. That's it. You simply got to be able to see it. That's it. Now for the x-intercept, now that one you're going to have to work for it. And to find the x-intercepts, basically, we're looking for the solutions. And by now, we've done a lot of finding solutions in class. You should understand that, hey, we got to solve this. We have x squared and x. We're going to have to factor. So how do we factor this question? The x game, right? So we factor the x game. It's negative 18 on top, negative 7 on the bottom. Bottom's negative. The right side's negative. The left side is positive. What two numbers multiply give you negative 18, but when you add them gives you negative 7? It is 2 and negative 9. So my factored form would be x plus 2, x minus 9. Right? Have I found the solutions? No. We have to make each factor equal to 0 and solve. It's going to make each factor equal to 0 and solve. What do we do here? Leave x by itself, move the negative 2 to the other side, turn to negative 2, x is equal to negative 2. And we do the same thing to the other factor. Voila. Those are my solutions, which means they are my what? X-intercepts. Bam. So I know that my x-intercepts are negative 2 and 9. If I want to write them as points, I would say negative 2, 0, and 9, 0. Awesome. Now, this was when it was given to you in standard form. So, hey, very easy to find your y-intercept. To find your x-intercept, you're going to have to work. Cool. Now, what if I already gave you something in factored form? Voila. Ooh, guess what? That's beautiful. One problem, though, is that sometimes you guys don't realize that, hey, dude, they gave it to you in factored form. Okay? It's important that you acknowledge what form they give it to you in because, hey, they give it to you in factor form, guess what? All you have to do now is make each factor equal to what? 0. Solve for x, what do we do? Just like we did before. X is equal to negative 2. X is equal to 9. If you're thinking, oh, it's the same problem as the other one, guess what? It is. It is, but it's just in a different format. The question is, can you get the same answers when they're in a different format? Now, the y-intercept, it still would be considered to be the constant. So there's two things that we could go ahead and do. Now I'm going to go ahead and rewrite the question here. I'm going to go and write x plus 2, x minus 9. I'm going to teach you two ways of finding the y-intercept, okay? Let me go and start by doing how one way is by converting it into standard form. So if I want to convert it to standard form, that means I have to multiply everything out. X times x, x squared. X times negative 9, negative 9x. 2 times x, positive 2x. 2 times negative 9, negative 18. Combine like terms, x squared minus 7x minus 18. And then it's in standard form now, and we can simply look at this and be like, oh yeah, the constant is my answer. So my y-intercept would be 0, what? Negative 18. Now, that is the long way of doing it, right? Sometimes they could give it to you in factored form, and it's more difficult than this. Maybe there's 3 or 4 factors, 5 factors, and if you try to multiply all that out, dude, it would take you forever. So one simple thing that we can do is, hey, if I want to find the y-intercept, I know that it's the constants. So guess what? I'm just going to focus on multiplying 2 times negative 9. Why? Those are both constants from each factor. If I multiply 2 times negative 9, what do I get? Negative 18. That's my y-intercept. Hopefully this helps. Go get it. You guys got this.